All right. Okay, good evening. We'll start. Can you confirm whether I'm clearly audible and visible? I will check from my end also. Okay, it's fine, right? Okay, it's fine. Right. Right, it's fine. Okay. So today we are into the second part of the general province discussion, and we are at a point where you are like 11 days from the exam, right? Just 11 days now. Just 11 days from the exam, right? So today is for your day, so I think you have spent your time effectively, right? Now these days for you ones who are sitting this time, right? It doesn't matter or it doesn't need what the day is, right? The only thing you do is working, and so on. That's it, right? That's it. It doesn't matter whether it's a Sunday, Saturday, weekends, doesn't matter, or weekdays, right? Okay, so 11 days, right? I hope all of you are doing good, right? And you are spending in good health, because these days health is also very important, right? Even if you got headache sometimes, right? Say you couldn't do anything for 2 hours because of a headache, right? Still it counts, still it matters. Maybe just 2 hours, but still it counts and it matters, right? That's how critical the time these days are, right? Last 11 days, right? Last 11 days, right? Okay, then without any further ado, we'll go to the discussion, right? We'll go to the discussion. Right, let me share my screen. All right, my screen is visible, right? Okay, so last day we discussed up to 25. We discussed up to 25, and we have to continue from 26. We have to continue from 26, right? 26. 26. Okay, that's a theory question from laser. Consider the following statements about the production of laser light. About the production of laser light, right? So, statement A. Statement A. There are more than two energy levels for for the medium of laser light. That is correct, no? Because minimum there should be two different energy levels, or more than that. Right? Minimum there should be two energy levels. Say there are three energy levels as E0, E1, and E2. Then what happens in laser is, right? What happens in laser is, right? From one of the energy levels, energy levels, these atoms are pumped to one of the higher energy levels, like this, right? Or it can be pumped to this level as well, and that process is called absorption in laser. That is called absorption, right? That is called absorption. And then between E2 and E1, or between E1 and E0, or between E2 and E0, right? Laser production can occur. So as a minimum, two energy levels is a must, right? Two energy levels is a must. So A is a correct statement. B, the polarization of stimulant photon and the stimulated photon are the same. Yes, that is same in terms of polarization, in terms of energy, right? In terms of all other features like wavelength, frequency, that is same. When energy is same, frequency is anyway same. When energies are same, equals HF. When energies are same, frequencies are same, right? And when frequencies are same, lambda wavelengths are also same, right? So they are also same, right? Then B is also correct. B is also correct. The output of the laser light can be obtained as continuous beam or pulses. Yes, possible, because with the way that we use these photons, external photons, right? With the way that we use these external photons, it changes, right? If you need pulses, can get pulses, or if you need a continuous beam, if the external beam is projected continuously, that is also possible. Then in this case, all ABC are true, right? In this case, all ABC are true, right? 27. If there's anyone who didn't have the paper, you can go to the part 1 live, right? Part 1 live video, and there I have pinned a message with the link for the paper, right? From there you can get the paper, right? 27. The corresponding wavelength and the electromagnetic wave of the radiation of maximum intensity from a person who can be considered as a black body at a temperature 36 degrees Celsius would be the Wien's displacement constant is 3 times 10 to the minus 3 millikelvins. Okay. Then we know Wien's equation is lambda d equals k, right? Lambda d equals k. Then lambda is given, lambda is asked. T is given, 36 means 309, 36, 309 in kelvins. And Wien's constant 3 times 10 to the power minus 3. 3 times 10 to the power minus 3. Then we need lambda. Lambda is 3 times 10 to the power minus 3 over 309. Right? Then 3 over 309 is 0.97. 0.97 10 to the power minus 2. 0.97 10 to the power minus 2. Then lambda is, if there is 9.7, that is 9.7 times 10 to the minus 2 here, and with this 10 to the minus 3, then 10 to the minus 3, right? Then that is 9.7 times 10 to the minus 6 is in meters. So lambda is 9.7 micrometers. Lambda is 9.7 micrometers. 9.7 micrometers, right? 9.7 micrometers. Then 9.7 micrometers are given in 3 answers, and you have to know which type of the electromagnetic wave is there in that region, right? So we know visible light is around 500 nanometers, right? Now this is micro, this is 900 something, no? Then visible light is around 500, and ultraviolet, that is less than that. Then this is infrared. Infrared is around 800 to 900, right? They are 800, they are like 800 to 1000 infrared. Then answer is infrared. 28. There is a large container of water in a closed room. In the beginning, at time t equals 0, the relative humidity of the room is 80%. Right, that is not saturated, no? Relative humidity is only 80%. Room is not saturated. If the temperature of the room is constant, the graph which shows the variation of relative humidity RH of the room with time is okay. Now, water is in a large container like this. Then over time, what happens is, we know over time, right, this is going to evaporate. This is going to evaporate. When this evaporates, right, number of water vapor in this atmosphere increases, no? Right? When that water vapor in the atmosphere increases, then it is getting closer to saturation. Then the number of particles which go from water to water vapor layer decreases, right? Then first hint is right, RH is increasing because number of water vapor in the atmosphere increases, so relative humidity increases. But over time, since the density of water vapor in that atmosphere increases, right, number of water vapor which goes from the water container to vapor layer decreases. So that is increasing with a decreasing rate. That is increasing with a decreasing rate. That is increasing with a decreasing rate, right? There's only one increase given with a decreasing rate. There's only one increase given with a decreasing rate, so it must be 1. Right? Only one increase given with a decreasing rate, no? So it must be 1. So likewise, easily got those answers. Right. Then 29. The figure shows the variation of pressure P and volume V of an ideal gas. The cyclic process ABCA, right? ABCA, no? Then A to B, B to C, C to A, right? ABCA. The temperatures at A, B, and C are TA, TB, and TC. Consider the following statements. Okay. Temperatures are given. Then we know PV equals nRT. And if you need to check about temperature, PV is proportional to T. Then check the product of PV. If you need to check about temperature, check the product of PV. TA, product of PV at point A is 4 into 1, 4. Then TB is product of PV, right? P is 1, V is 4, still product is 4. And for TC, product is P is 1, V is 2, right? Then there is 2. Then TA equals TB, right? And TC is less than both of them. Statement A is correct. Then statement A is correct. Statement A is correct. Then statement B. In the cyclic process, the gas has absorbed heat, right? The gas has absorbed heat, right? For that, we know clockwise processes, right? Simply we can get it if you know these things properly, right? Clockwise processes are absorptions, right? Delta Q is plus in clockwise process, and in anticlockwise processes, right? In anticlockwise processes, delta Q is minus, right? Plus means absorptions, and minus means liberations. Now in this case, this process is clockwise. So that is an absorption. That is clockwise. No? B is also correct. That is an absorption. Right? C. And a adiabatic process is shown by CA. Right? We know if a process is adiabatic, delta Q should be 0. If a process is adiabatic, delta Q should be 0. Right? If a process is adiabatic, delta Q should be 0. Then delta Q equals delta U plus delta W. Right? Now we are given about CA, then delta U CA, delta W CA. We are given about CA. Right? Then about CA process, there's a difference in temperature. No? There's a difference in temperature, which means delta U is non-zero. There's a difference in temperature, right? Because we checked the temperatures before, right? There's a difference in temperature, which means delta U is non-zero. That is non-zero. And delta W is given by area under curve. No? Now there is an area under CA curve, which means delta W is also non-zero. If both of them are non-zero, delta Q must be non-zero. No? Delta Q CA, right, must be non-zero. It must be non-zero. If other two values are non-zero, then it cannot be an adiabatic process. C is wrong, then only AB, it's true. Only AB, it's true. Right? Only AB. Then 30 op amps. Now for this time exam, op amps is very important, right? Op amps are very important for this exam. Right? The figure 2 shows the inputs V1 and V2, which are applied to the operational amplifier shown in the figure 1. The frequencies of voltage signals of V1 and V2 are the same. Which choice shows the output V out correctly? Okay. So this is actually a summing amplifier. This is a standard amplifier that we discussed in the theory. Right? This is a standard amplifier we discussed in the theory. That is a summing amplifier. Then, now first thing, check these currents. Now, that is feedback. Since there is feedback, we know this is 0, then V1 equals 0. This point is also 0. That is feedback. V1 and V2 are positive voltages given. Then current flows in this direction. Right? Say this current is I1 and this current is I2. And we know first golden rule, there are no current inflows through input terminals of an op amp. Then this current is going to flow through 50. It is going to flow through 50. Right? I1 plus I2 is going to flow through 50. Right. Now, to find I1 and I2, what we can do is apply delta V equals IR for R1 and R2. See, so we know delta V equals IR, and current is given by delta V over R. No? Then if we apply this for these two, delta V for first one is V1 minus 0 over R1, right? Say that current is I1, no? I1. Then I1 is given by V1 over R1. Then second current is I2. Potential difference is V2 minus 0 over R2. Then that is V2 over R2. Then I1 and I2 are known. If I1 and I2 are known, we can apply delta V equals IR again for 50 kilo ohms, no? Right? Then for 50 kilo ohms, delta V equals IR. Now current flows from 0 to V out. Then it should be written as 0 minus V out. Right? Is IR, then current flow here is I1 plus I2. Right? R is 50. Now all values are in kilo ohms, right? I will plug this R1 and R2 also. This is V1 over 10 and this is V2 over 5. Now all values are in kilo ohms, then minus V out equals I1 V1 over 10 plus I2 V2 over 5 times 50. Now by 5, this cancels, no? By 5, then 5 times 10, 2. Right. Then V out equals, if I write the minus sign on the other side, and this is 10, no? Multiply inside, then 10 times V1 over 2 is 5V1. Right? Then 10 times V2 is 10V2. Final answer is this. So V out is this. V out is minus 5V1 plus 10V2. Right? Now, using this, since V out is known, we can find the value of V out. Then V out equals minus, right, 5V1. V1 is given. V1 is 0.1. Then 0.1, right, plus 10V2. V2 is 0.2. Right? Then 2 plus 0.5, 2.5. Then V out becomes minus 2.5. Minus 2.5 volts. That's it. Now we know V out as minus 2.5 volts. Then from the output graphs, first should go to minus 2.5. There's only one answer which has gone to minus 2.5. Second one. Right? Second one. See how easily you can do when you know these things properly. Right? Recall these theories if you can't remember. Okay. 31. As shown in the figure, two resistors R0 and R are connected in parallel. The graph which shows the variation of effective resistance RAV with the change in variable resistor RH. Okay, so they are in a parallel combination. No? Then we all know, right? That is added as 1 over resistors, then 1 over RAV equals 1 over R plus 1 over R0. Right? Simplify this. 1 over RAV equals, this is R0 over R plus R0. Then RAV equals RAB equals RR0 over R plus R0. Right? It is easier for me to isolate the variable. Then to isolate the variable, now my variable is R now. To isolate the variable, I'm going to divide both by R. Both numerator and denominator by R. Then this becomes R0. And here 1 plus R0 to R. Right? divide both numerator and denominator by r. Right. Then r changes. Now you have to check these ends. First, check the ends. Right. In most of the electricity questions, the same thing is there. When we check about the endpoints, we can get more than 90%, 80% of an idea. Right. Then first one, when r equals 0. When r equals 0. Right. When r equals 0, r not over 0. No? Anything over 0 is infinity. Right. Then r not over 0. R not over 0. Anything over 0 is infinity. Then this goes to infinity. Right. Then r not over infinity means 0. Right. R not over infinity means 0. This is how it is simplified. RAB equals then r not over 1 plus 1 over 0. 1 over 0 is infinity. Then this becomes r not over infinity. R not over infinity, that is 0. Then graph starts from 0. Right? One point is that graph starts from 0. And then you can check when r goes to infinity. When r goes to infinity, what happens for RAB? RAB is r naught over, right, 1 plus r over infinity. Anything over infinity is considered as 0. Then r over infinity is 0, which means 1 plus 0 is 1. This goes to r naught. RAB goes to r naught when it goes to infinity, right? Then there's only one such curve starting from 0, and when r goes to infinity, it goes to r naught. One such curve. Obvious answer is 2. Obvious answer is 2, right? So likewise, pick those answers easily. Right? Likewise, pick those answers easily. Right. 32. Again, a calculation. A body P of mass 0.2 kilograms. A body P of mass 0.2 kilograms is attached to the free end of a 20 centimeters long light string, and other end is connected to the axle of a smooth horizontal circular disc. Right? The disc is able to rotate freely about the vertical axis through the center O of the disc. The disc is rotated with a uniform angular acceleration of 4, again alpha. Alpha is 4 rad s minus 2. If the breaking tension of the string is 400 newtons, how long does the body P take to move away radially? Right, to move away radially. Okay, then right, then to move away radially. Then since it travels in a circular motion, right, we know first we can find its omega, right? When it is in this maximum tension, then F equals ma. This is towards center. This is a circular motion. F equals ma towards center. Then only force acts is tension. Only force acts here is tension towards center. Maximum tension that it can go up to is 400. Maximum tension that it can go up to is 400. Mass is given 0.2. Mass is given 0.2. And A is r omega squared. No? So we know centripetal acceleration. Right? Centripetal acceleration is A equals r omega squared. Then radius is given 20 centimeters. 20 centimeters long. Then 20 means 0.2 meters. No? Omega squared. Right? Now this is, see, easily simplifiable. 400 equals, this is 4 times 10 to the minus 2 omega squared. 4 times 10 to the minus 2 omega squared. Right? Then 4 cancels. Here 100 remains. Then omega squared equals 10 to the power 4. Then omega equals 10 squared. Omega is known. Omega is 100. Then if omega is known, once it acquires this omega only, it is going to break. Right? Once it acquires this tension only, it is going to break. Then if you need time up to that point, then apply a rotational motion equation. Omega 2 equals omega 1 plus alpha t. Then omega 2 is 100. Omega 1 0. It is starting from rest. And alpha was given as 4 t. Then that's it. 100 equals 40. 100 equals 40, right? Then t is 25 seconds. 25 seconds, that is 25, right? A rotational motion, a circular motion, and a rotational motion combination. Circular and rotational combination, right? 33. 33. The column of air in a tube closed at far end vibrates with a fundamental frequency of 660 Hz. The temperature of air is 27. What is the fundamental frequency of the air in the tube when the temperature becomes 30? Assume 1.01 square root as 1. Okay. That is given. Now this kind of a scenario is given. Right, then we know when air mediums, for air mediums, V is given by root gamma RTOM, no? Right? Root gamma RTOM. And if the tube is same, lambda is also same. If the tube is same, lambda is also same, because in this case, lambda of O is going to be L. Now, if this L is unchanged, right? If the tube is same, L is unchanged, then lambda is unchanged. Then if I expand V as F lambda, right? F lambda, and now I'm going to cancel these constants that I don't need, right? For these two cases, lambda is a constant, same tube, gamma is a constant, R is a constant, M is a constant. Then the only thing I need is F is proportional to absolute temperature. That's it. F is proportional to absolute temperature. Then apply this for these two cases given. In the first case, 660 proportional to root 27 means 300. In the second case, I need F, right? I need F proportional to temperature is 300, sorry, 30. 30 means 303, no? 303, right? The simple divide these two, divide these two. Then 660 over F equals square root 300 over 330, 303, right? Now it cancels by 3, no? See, this cancels by 3. When it cancels by 3, it becomes 100 over 101. 100 over 101. Right. Now, if you subject F, now F is given by 660 times, right? 101 over 100, no? Right? So this is exactly the given value now. This is exactly the given value now, right? So see these hints, 660, and this is root 1.01, right? 101 over 100 is a given value. Then this is given as 1.005. 1.005. Then final answer 660 times 1.005, right? And it is 663. It is 663, answer 2. Right? 663. 34. 34. Right. When the graph of the image distance V against the linear magnification M is drawn for a real images formed by a converging lens, the gradient and intercept are G and C. Okay. Then for real images, no? 1 over V minus 1 over U equals 1 over F. We know all real images are going to form in front of the lens. Then V is minus, right? U is plus, then plus and minus is minus. It is a convex lens, so F is also minus, right? There is a convex lens, that is also minus. Then this is 1 over V plus 1 over U equals 1 over F. 1 over V plus 1 over U equals 1 over F. 1 over V plus 1 over U equals 1 over F. Then to create magnification, it is easy to multiply the entire equation by V. Then 1 plus V over U equals V over F. V over U is magnification, then 1 plus M equals, right, V over F. Then magnification is given by M equals, right, this is 1 over F, V minus 1. Now, right, identify the curve. This is the intercept C, and this is the gradient M, this is X, this is Y. That is mx minus c. That is mx minus c. The graph is mx minus c. Graph is right? Mx minus c. Mx minus c means something like this kind of a graph, mx minus c, right? And it says, right, now for this one, gradient is g and this intercept is c, right? And we can see intercept is 1, actually. Intercept is 1. Then by keeping an identical converging lens in contact with the first lens, the graph of the real image distance against the linear magnification is drawn. The gradient and intercept of the graph. Okay. Now, if two lenses are kept in contact, that is going to act as a combined lens. That is going to act as a combined lens. Then for the combined lens, we know, we can find the focal length as 1 over f equals 1 over f plus 1 over f. Alright. Now, for this case, this is also convex minus, this is also convex minus. Then 1 over f equals, this is minus f over 2. Now, f becomes minus f over 2. Right? Minus f over 2. Then, what has happened? Focal length is half. Now, go to the gradient. Gradient is 1 over f, no? Now, from this, focal length is halved. When focal length is halved, gradient is doubled. Gradient is doubled. When focal length is halved, gradient is doubled. Then for the next one, this should be 2g, no? If that is doubled, and there's no change of intercept because intercept is 1. Intercept is 1. Then if we plot the second curve, intercept is same as 1, like this. And gradient of the graph will be increasing like this. Gradient of the graph will be increasing like this. So you are going to get something like this. Say this is 2g. Right? Gradient is double. Gradient is double. Then 2g and c. 2g and c. A different type of a question. Huh? A different question. A different question. Not a regular, not a usual question that we usually get. That's a different one and a good question. That's a good one. Right? Next, 35. The figure shows a combination of three tubes of lengths capital L, L1 and L2, which are connected to the point P. The radii of them are R, R1 and R2 respectively. A steady, streamlined viscous fluid flows along the tube. Entering from end A, the pressure at the points A, B, C are 2P0, P0 and P0. Right. Then 2P0, P0 and P0. 2P0, P0 and P0. Right. Then the pressure at the common junction P of the tubes. Right. Pressure at the common junction P of the tubes. Right. Okay. Then let's consider that pressure as P. Okay. Depends on. Okay. Then have to apply an equation and see. Now it says that enters, right, a steady streamlined viscous fluid along the tube entering from end A. Okay. It enters from A, which means these two are going to be exits. Right? We know always volume flow rate should be equal. Then V over T, volume flow rate along AP equals simply inflow equals outflow. Inflow equals outflow. Right? This is the inflow. In equals out. Then outflows are, there are two outflows, V over T from PB and again V over T from PC. Right? So we know for such cases we have only one equation, Poiseuille's equation. Expand this using Poiseuille's equation. And that is the only equation which connects pressure difference, radius, losses. This is phi delta V. Then we'll write delta V along AP. Along AP delta V is 2P0 minus P. Then 2P0 minus P. Phi delta V R to the power 4. Then there is capital R to the power 4 over 8 eta L capital L. Right. For next one, phi pressure difference is P minus P0. And its radius is R1. Then it should be R1 to the power 4. Over 8 theta L1. And for this one, phi P minus P0. Right, P minus P0. R2 to the power 4 over 8 theta L2. Right, now see what cancels off. Phi is common, cancels off. Right, 8 theta is common, 8 theta cancels off. Right, that's all. and P depends on everything else which remains in the equation. P depends on everything else which remains in the equation. Then depends on coefficient of viscosity, wrong. Depends on length of fold tubes, yes. Depends on radii of fold tubes, yes. Then B and C. B and C, right? Now, without using the equation, we can't say anything, even though that's a statement question. Question is a statement, right? Without using the equation, we can't do anything or we can't say anything, right? Okay. Then 36. The ratio between the radii of two planets is K1, right? The ratio between the acceleration due to gravity on the surfaces of them is K2. The ratio between the escape velocities. Okay. For escape velocities, we have proved two equations, right? One equation of escape velocity is root 2gm over r. This is the popular equation. Root 2gm. Root 2gm over r. Or we can write the same equation as root 2g dash r. Right now, in this case, since gravitational field intensities are given, I'm going to go with this equation, second one. Right, I'm going to go with the second equation. Then, if we use this for these two cases, right, if I use this for these two cases, second, right, if I use this for these two cases, that's it now, right here, right. If I use this for these two cases, right, for these two cases, now escape velocity of one, let's say v1 is root 2 g dash 1 r1. For the second one, v2 is root 2 g dash 2 r2. Then divide these two. v1 to v2 equals square root, right? 2 cancels, no? Then g dash 1 over g dash 2 comes here, and r1 over r2 comes here. R1 over r2 comes here. Then acceleration due to gravity. This ratio is given. This ratio is given as K2, and radius ratio between radii is given as K1. Then K1. That's it. Root K1 K2. Root K1 K2. It's 1. Right. Root K1 K2. It's 1. 37. 37. Infinitely long free straight conductors are placed on the plane of the paper so as they pass through the points ABC without touching one another, as shown, right? Then an ABC is a regular triangle, right? If there is a regular triangle, we know this is 60, this is 60, right? And if I extend this, okay, and this is going to be a perpendicular line if we extend this, then O center of the triangle is and AO equals 20. Okay, so we know center of triangle, centroid of triangle or center of triangle divides any angle bisector in 2:1 ratio. No? Then if this side is 20 centimeters, it divides this in 2:1 ratio. This side is obviously 10 centimeters. Right, it divides in the 2:1 ratio. Then that is 10 centimeters. Okay. Then the conductors carry currents 2 amperes towards the direction shown. The magnetic flux density produced at tau is okay. Then if I apply to be a conductor first, right, apply right hand rule and see and check the directions. by BA, that is inverse cross. By BA, that is cross. And by CA apply, that is dot. That is dot. Then that cross to that dot is going to cancel. Then these two are going to cancel their magnetic flux. Right? They are going to cancel their magnetic flux. And from the bottom 2A, right? Apply this again. Right? From that bottom 2A, that is outwards. That is outwards at toe. Then from this 2A, an outward one remains, which means that is going to be outwards at toe. That is going to be outwards. Magnetic flux density is given by B equals mu naught tau 4 phi. Right? If the conductor is infinitely long, that spreads to both sides, then 2I over R. Right? Then mu naught tau 4 phi is given 10 to the power minus 7. Right? 10 to the power minus 7 times 2I, I is 2 over R. R is 10 centimeters, distance from the wire to point, 10 centimeters, 10 times 10 to the power minus 2. Right? Then, right, as a number, what comes here is 4. Right? As a number, 4 comes. Then there are only 2 answers with 4. Right? We know that was outwards. Then there is 4 times 10 to the minus 6, and that is out from the plane. It should be then and into the plane. No, out from the plane. It's 2. Right? It's out from the plane. Right? Value is 4. Right? 10 to the minus 6 is also coming. This 10 to the minus 1. Then 10 to the minus 6. But no need to check the 10 to the power. Right? If there is 4 and we know that is outwards. Right? 4 outwards. Only one answer. Then 38. 2 point charges plus Q1 and plus Q2 are placed at the points A and B on a flat surface. The electric field intensity at point C is 0. Okay, then that is a neutral point. No? There is a neutral point. Right? There is a neutral point. C is a neutral point. N, P, that's a neutral point. Right? Then we know when it comes to neutral points are always closer to the smaller charge. Right? Neutral points are always closer to smaller charge. And they are far from the higher charge. Right? It should be closer to smaller charge, then it is closer to Q2, which means Q2 should be less than Q1. Right? Q2 should be less than Q1. Then statement A is correct as a statement. Statement A is correct as a statement. Then statement B. At the midpoint D of AB, the direction of electric field intensity is towards AB. Right, at D. So we know, right, see, an important idea again. We know if neutral point is here at C, right? If neutral point is here, right? To the left of neutral point, the field of A is higher, right? And to the right of this field, the field of B is higher, right? Neutral point is at C. Point is at C. Then at D, A's field is higher, that is stronger, then the direction is A to B. That is also correct. So B is also correct. Then C, the point with the maximum electric field intensity is D. No. Right? Always maximum intensity should be close to the highest charge. Right? Maximum E is closest to the highest charge. Then it should be close to A. That is not point D. That is wrong. Then in that case, only A, B are correct. Only A and B, it's 3. Right? Only A and B, it is 3. 39. Right? Practice these questions and improve your confidence and comfortability. 39. In the following setup of capacitors shown in the figure 1, the area of each plate PQR and S is A. Right. The gap between each couple of plates is D. The capacitance measured in between X and Y is C. Okay. Then the question is, in between the capacitors shown in figure 2, the area of each plate is A, the gap between each couple is D, the capacitors measured between A and B is okay. Then first you have to check how many capacitors are here in first setup. Let's assume this point as plus. If there is plus, this plate is plus. Right, this plate is also plus. If this is minus, this plate is minus, this is minus. Then there is a capacitor between these two. There is a capacitor between these two. Right, and these two capacitors are parallel because both of their positive terminals are at x, and both of their negative terminals are at y. Then they are parallel. Then CXY, equivalent capacitance of x and y between x and y is 2C. Right, parallel no 2C. Then 2C can be written as epsilon naught A over D. Right, and CXY is given as C. This is one thing. And then about the second case given, let's assume A as plus. If A is plus, this is plus. This is also plus. If B is minus, this plate is minus, this is minus. Now in between plus and minus, there is a capacitor. In between plus and minus here, there is a capacitor. In between plus and minus here, there is a capacitor. Then there are three capacitors. Of all of them, positive terminals are at A and negative terminals are at B, which means they are still parallel. Then C between A and B, CAB is 3C. CAB is 3C. Then there is 3 times epsilon naught A over D. 3 times epsilon naught A over D. Right? Then using C, we can give a substitution here. Right? Then 3 times epsilon naught A over D from here is C over 2. No? That is C over 2. And that is 1.5 C. That is 1.5 C, 1.5 C. Right? 1.5 C. Got it? 40. A current of 1 ampere flows into the circuit shown in the figure. A current of 1 ampere flows into the circuit shown in the figure. The reading of the ideal voltmeter is 1.2 volts. Reading of the ideal voltmeter is 1.2 volts. The resistance of the resistor R is. Right. Reading of the voltmeter is 1.2, which means potential difference between these two, say these points are x and y, is 1.2, no? Which means Vx minus Vy equals 1.2. Right? Then let's assume the current flows here is I, and if there is I, this should be 1 minus I, no? This current is 1 minus I. Right, now to find that I, we can write Vxy, no? Write the potential along the circuit. Write this potential along the circuit starting from Vx to the opposite direction of current plus IR, then plus I is 1 minus I is 1 minus I, right? R is 2. To the same direction of current minus IR, then minus I, R is 2. Now we at Y. Then Vx minus Vy equals, right? Vx minus Vy equals, this is 2I, sorry, minus 2I. This is, 2I minus 2 times 1 minus I. Now Vx minus Vy was given as 1.2. That is 1.2. Then here this is 2I, right? Minus 2 minus becomes plus 2I, right? Then this is 3.2, right? 3.2 equals 4I. And we have simple I now. Then I equals 0.8 amperes. Right? If I equals 0.8, now currents are known. We have a single loop. For that loop, I'm going to use Kirchhoff. Right? This is not the only way, but I'm going to use Kirchhoff for the single loop. Right? That is easier for me. Sigma E equals sigma ER. Sigma E of the circuit is 0. Right? Sigma E of the circuit is 0. Then sigma ER in this direction, we are applying in this direction, no? Then I flows, I is 0.8, no? 0.8 flows through two resistors, 2 plus 3. right? Minus opposite direction. 1 minus I means 0.2, no? If I is 0.8, 1 minus I is 0.2. 0.2 flows to 2 resistors, 2 plus R. 2 plus R. Right? Then take this to the opposite side. 0.2 times 2 plus R equals, this is 0.8 times 5. 0.2 times 4 is here. Then 2 plus R equals 20. Then R equals 18. R equals 18, it's 4. R equals 18. 18. R equals 18. Right? R equals 18. Right, up to 40 questions we have done now. Give me 1 minute. One second. Right. Next, 41. Right. Any questions so far? 41. 41. 41. Three liquids ABC are at temperatures 30, 40, and 50 respectively. Same masses of these liquids are mixed in a container and stirred well. These liquids mix with one another and no heat lost to the surroundings. The final temperature of the mixture is 35. The specific heat capacities of ABC, SSB, and SC, the relationship. Okay. If a substance has increased its temperature, that is a heat absorption. If a substance has decreased its temperature, that is a liberation. So we know always, right? Total Q of absorbed heat equals total Q of liberated heat. Right? Then absorption is from the ones who has increased temperatures. Then from 30 to 35, A has increased, no? Then QA is here. And 40 to 35, B has decreased. So there is a liberation, then QB. And 50 to 35, C has liberated QC. Right? Q equals MS theta. Masses are equal, it says. Then MSA. Theta here is 30 to 35, 5. Then QB, mass, SB, and 40 to 35, it's 5 again. QC, MSC, 50 to 35, that is 50. M2, M cancels off. Then by 5, this cancels. By 5, this cancels. 5, 5, and 3. Then it's a simple one. SA equals SB plus 3SC, right? It's 5. It's 5. Right? That's a simple calculation, not a big deal. 42. 42. The length, L and cross-sectional area of rods AB and BC are same, and they are connected at the end AB. Sorry, at the end B. The curved surface of the combination is lagged to prevent heat loss. Okay. K is twice. Then this is 2K. If this is K, right? The distance from A to the point at which temperature is 50 degrees Celsius is when the combined rod becomes the thermal equilibrium is. Okay. So when we apply conductivity equation, we can't use it to the system at once, right? We can't use it to the system at once, right? We can't use it to the system at once, right? So one thing we can do is we can apply the same equation separately, right? Or else you have to find the equivalent K to the system and apply to the system, right? Now I'm going to go with the first method. We know Q over T is same if they are in series combination. Q over T is same. Then Q over T AB equals Q over T BC, right? Then this is 2K, right? Areas are same. It is anyway going to cancel, right? And let's assume temperature of this midpoint is theta, right? Let's assume that as theta. Then this is 100 minus theta over L. And for this one, K, A, theta minus 0, right, over L. No. Now, K to A to L2, K to A to L cancels, right? Then 200 minus 2 theta equals theta, right? Then theta equals 200 over 3. That is 66 point something, no, 66.6. Then for sure I can say the point of 50 is to the right of this point, to somewhere here. The point of 50 is to the right of this point. So it should be to somewhere here. Should be somewhere here. Because heat flows from 100 to 0. And midpoint is 66. Right? Midpoint is 66. Then 50 is somewhere here. Then to do another calculation, I'm going to take this rod B to do another calculation. Right? If we consider rod B, right? Now we know this end is at 200 over 3 and this end is at 0 and 50 is somewhere in between. 50 is somewhere in between. Let's assume distance to this point from this end is x. Then in this case, this should be L minus x. No? It should be L minus x. Now my target is finding x. If x is known, if I need distance from A, then L plus x is going to be the answer. No? L plus x is going to be the final answer. Then still these two are same because they are the same rod. Then again Q over T is the same. Then Q over T equals Q over T. Q over T equals Q over T. Then for the first one, 200 over 3 minus 50. Now I'm not going to write all other constant terms. K is constant now, area is constant, length is constant. Writing only the temperature difference is enough, right? Sorry, lengths are not constant. Then temperature differences and lengths are enough. Then 200 over 3 minus 50 over length is x. And the other side 50 minus 0 over length is L minus x. Right? Then 200 over 3 minus 50 is 150 means 50 over 3. No? Then 50 over 3x equals this is 50 over L minus x. 50 cancels off. Cross multiplication. Then 3s equals L minus x. Then 4x equals L. X equals 0.25 L. L over 4. 0.25 L. Right? Therefore, what I need is the distance from A. Right? Therefore, from A, distance from A means, right? Distance from A means L plus 0.25 L. That is 1.25 L. 1.25 L, that's a good question, right? A little bit different, good one, right? 1.25 L. 43. 43. As shown in the figure, two sound sources move with the same velocity. Two sound sources move with the same velocity. U towards BC. Same velocity, U towards BC. Along the line BC, emitting a sound of frequency F. When the sources are at V and C, a person at point A and ABC makes a regular triangle. Then if that is regular, we know this angle is 60, 60, this also 60, right? The velocity, if the velocity of sound is V, due to the sources, the person at A, right? Number of beats are asked, right? Observer is at A. Observer is at A. Then, if we dissolve this B, because always we can apply Doppler's effect only along the line which connects source and observer. Only along the line which connects source and observer. Then we should be from B to A, velocity of sound through air, and I need velocities in that direction. Then in this direction we have U cos 60, U cos 60, and from that the relative velocity is opposite U cos 60. Right? Similarly, now when we apply here, this is how we should go. This is how we should go. Right? This is how we should go. This is how we should be. And about U, we know this component of U is, see, this component of U is U cos 60. U cos 60. Right? Then the relative velocity is opposite U cos 60. Opposite U cos 60. Right? Then let's say frequency due to this B is FB and frequency due to C is FC. Right? Then apply Doppler's effect. FB equals velocity of sound through air with respect to observer. Observer is now at rest. Observer is now at rest. Then only V comes. Then below, velocity of sound through air with respect to source. With respect to source. Now, with respect to source, V is upwards, U cos 60 is downwards. Then V minus U cos 60 into real frequency F. Right? Then let's keep it like this and write FC. Then for FC, similarly, I can write observer is at rest V and velocity of sound through air with respect to source is, right? With respect to source is, that is V plus U cos 60, real frequency F, right? Now, we can clearly see, right? We can clearly see FB is greater than FC, no? Because denominator of FB is less. Since denominator of FB is less, FB is greater than FC. Then number of beats should be, delta F, should be FB minus FC. FB minus FC. Right? Then VF is common, take it out. Then here 1 over V minus U cos 60 is half, no? Right? Minus here 1 over V plus U cos 60, then V plus U over 2. V plus U over 2. Right? Now I have to simplify. I have to simplify now. I have to simplify. Right, now common denominator is going to be V minus U over 2 times V plus U over 2, no? Right? Then here what comes here is V plus U over 2 minus, from here, minus V plus U over 2. Right? Then the denominator here is a square of two squares. It's like A squared minus B squared, A plus B, A minus B. It can be written as B squared minus U squared over 4. Right? And here V cancels off. Right? U over 2 plus U over 2 is U. Then apply the common denominator 4. Then when 4 comes here, 4UVF over 4V squared minus U squared. Right? So number of beats is here. Number of beats is here. That is in answer 5. That is in answer 5. That's a good one. Right? That's also a good one. Right? 44. A beam of electrons accelerates from rest under potential difference V. the mass and charge of an electron are m and e respectively. The Planck's constant is h. De Broglie wavelength of the beam is okay. Then we know for moving charges, for any moving charge, we can apply W equals Q delta V from electric fields, and always W represents kinetic energy. Then half mu squared equals Q is E, this is an electron, and potential difference is given as V. Then U is given by, right, 2 EV over M, its square root of U is known. Right, for de Broglie equation, for de Broglie wavelength, we know we have only one equation, lambda equals h over mu, de Broglie equation. Then h over mu for u, for the speed, we have here 2 ev over m. Now here you have square root m, this is m, then square root m to m cancels and this becomes a square root. Then lambda equals h over square root 2 m ev, right? Square root 2 m ev, h over square root 2 m ev. 2 m ev, then 2, right? For 44 it's 2, right? That's kind of a normal one. 45. A body P of mass 10 to the minus 3 kilograms and charge plus 1 microcoulombs is kept at point B, 1 meter away from a fixed body at A, 1 meter away, okay, of charge plus 2 microcoulombs. The body P is allowed to move if 1 over epsilon naught, okay, the speed P gained after moving a large distance would approximately equal to, large distance means it goes to infinity, right? Then we can say, total energy at B equals total energy at infinity, right? Then total energy at B, no kinetic energy, but there's a electric potential energy. Electrical potential energy is written as 1/4 epsilon naught Q1 Q2 over R, and there's no electrical potential at infinity, but it has a speed, then a kinetic energy is there, half mv squared. Simply, this total electrical potential energy is converted into kinetic energy. Total electrical potential energy is converted into kinetic energy, right? Then 1/4 epsilon naught is 9 times 10 to the power 9. 9 times 10 to the power 9. Q1 Q2 1 times 2, right? Micro, then 10 to the power minus 6 to minus 6 minus 12. R is 1. Half mass is 10 to the power minus 3 V squared, right? Then see, 10 to the power minus 12, this is going to cancel nicely. 10 to the power minus 9 to minus 12 minus 3, that minus 3 to this minus 3 cancels off. Then 9 times 2, 18. 18 times 2 is 36. Then 36 equals V squared. V equals 6. V equals 6. Right? V equals 6. Right? V equals 6. We have come to 45 with that. Right. These last set of questions are kind of very good ones, good questions. One second again. Okay. Right. Let's see. Last 5. 46. 46. Right. 46. 46. The figure shows a region of uniform magnetic field of flux density B into the PQR horizontal plane and another uniform magnetic field of flux density B out of the QRS horizontal plane. Both fields are at right angles to the planes. The XY conducting rod is placed very close to PR at time equals 0 and it is moved towards QS with a constant horizontal velocity. The graph which shows the variation of electromotive force E induced in between the ends of the rod with time is okay. So we know we have a proved equation for induced EMF of a rod that is equals BLV. No, that is equals BLV. Induced EMF of a rod is given by E equals BLV. Right now, to include time into this, we can divide both sides by T. No? Now, when it is divided by T, L over D creates here. What is L over D? That's a length over time. That length over time is going to be a velocity again. Right? Length over time is going to be a velocity again. Then E over T equals, this is like, right, B. L over D is a velocity again. That is not the velocity of the rod, right? But that's a velocity term. No? That's a velocity term, right? And say that is U V, right? U V. Then E is given by B U. Now let's assume velocity of the rod dash V. Then that might be easier. We can easily write this then at once, right? If the velocity of the rod is V, then this is also V, right? Then this becomes BV squared T. BV squared T. Right now, that's it. Isolate these terms. T is our X variable. This is the gradient, right? And this is the Y. Y equals mx. And at some point here, since fields are in opposite direction, it should go to 0, right? It should go to 0, right? Y equals mx, right? That's a linear curve, right? And it is minus, it can be minus, right? It can be minus because this cross field decreases over time, no? Then the change of B is coming as a minus value. I didn't plug the minus, I just checked the shape. That is linear. That's the only thing I need. That is linear, right? For sure, you know, it is going to be 0 in between because here fields are equal in at the midpoint. At the midpoint, fields are equal in magnitude and opposite in direction. So it is going to be 0, right? In between 0 and it should be linear, right? In between 0 and it should be linear, it is 3. It is 3. Right, after that point, again, magnetic field is opposite. Huh? Opposite means direction of induced EMF is opposite. So it cannot be 1, then it is 3. Right, so likewise, can isolate the answers when we know this properly. You should be familiar, right? If you are not familiar, go through these theories again and again and familiar yourself, because when it comes to induction, that's a definite MCQ. Huh? Magnetic induction is a definite MCQ. Right, for sure, you are going to get it. That's a definite MCQ. 47. A meter ruler is made of a material A and its accurate at 0 degrees Celsius. When it is used to measure the length of a metal rod B at 30, its reading is 50. Okay. Then if its reading is 50, first we can see what the actual length of that B at 50. What the actual length of V at 30. Then L2 equals L1, 1 plus alpha 0. Then L2 is the length of B, right? L2 is the second length of B, right? Up here LB, say that is LB, second length of B, or the measured length of B, LB. L1 is 50 because at 0 it shows the correct reading, no, 50. Then 1 plus alpha, temperature difference is 30 to 0. Temperature difference is 30 to 0. That is 30. Then LB equals 50, 1 plus 30 alpha. Right? LB is known. Now what we need is the actual length of B at 0. Actual length of B at 0. Then apply the same equation for B. Again, L2 equals L1, 1 plus alpha theta. Then actual length at 0 is what we need, right? Actual length of 0 is what we need. Then say that is L2. Now L1 is given by L1 is given by LB. L1 is given by LB. Sorry, L2 is LB, right? L2 is given by LB, right? We need actual length of rod B at 0, right? Then it should be taken from 30 to 0. 30 to 0. Then final length is lesser than the initial length, 30 to 0. Right. Then at 30, we know it goes LB, no? Right. At 30, it goes LB. Then at 30, it goes LB. Then 50 times 1 plus 30 alpha. Alpha 1, right? Sorry. Alpha 1. Alpha 1. Then L1 is what I need. The length at 0 again. 1 plus. This is alpha 2. Alpha 2. It is taken to 0, no? Temperature difference is 30 again. Now L1 is 50 times 1 plus 30 alpha 1 over 1 plus 30 alpha 2. 1 plus 30 alpha 1 over 1 plus 30 alpha 2. Right? That is 1. No? That is 1. Right? I applied the same equation for both cases. Same equation for both cases. Right? Same equation for both cases. Right? A is measuring the actual length at 0. Then I found the length of A. Found the length of A at 30, and that is the initial length of B, right? And again, B is taken to 0. Then initial length of B is that value at 30, yeah? At 30. Then take it to 0. Forty-eight. 48, it's also a different one and a good one, right? The capillary tube A of internal radius R and thickness of the glass wall is D, immersed vertically in a liquid of angle of 0 contact angle. Then the liquid rises to a height h. Okay, then we know for a tube, capillary rise is given by, right? For a tube, right? This capillary rise is given by h rho g equals 2t over r. Then radius of this tube is r, no? Radius of the tube is r. Radius is r. Since radius is r, h rho g equals 2t over r. Say that is equation 1, right? Then the liquid rises to height h. Another capillary tube B of internal radius 2r, immersed in liquid so that both tubes are coaxial as shown in the figure. The height of the liquid in the space between the tubes is, right? This one is asked, right? Then first thing we have to identify these lengths properly, right? This is the common axis here. See, this is the common axis here. This is the common axis, right? If there is a common axis from here to this point, there is radius, no? R. Let me draw it again. Otherwise, that won't be clear enough, right? Then this is the tube inside given, right? And this one is the tube outside given. This one is the tube outside given, right? And this is a cross section, no? This is a cross section, right? This is a cross section. Then the common axis is here. Common axis is here, like this. Then length from here to here is a radius, no? And this is depth. Sorry, that is the thickness D. That is the thickness D, right? D and R. Then we know radius of this larger tube is 2r, no? Radius of the larger tube is 2r. Now, if this distance is x, right? Finding these distances is the thing here. If this is x, right? Now, we can clearly see 2r equals this x plus d plus r, no? Then x is r minus d. X is r minus d. That x is known. X is r minus d. Right? X is r minus d. Then uh, if we need the height at here again, if we need the height at here again, right? Height at here again, then we know this. Now, first thing is this is not a spherical meniscus, right? That is a cylindrical meniscus. This one is a cylindrical meniscus. About cylindrical menisci, right? We know this. This is a cylindrical. No? This is a cylindrical meniscus. That is important. That is a cylindrical one. That is a cylindrical one. Right? For a cylindrical meniscus, we know delta P is. For a cylindrical meniscus, we know delta P is written as not 2TOR, that is TOR. Right? That is TOR for a cylindrical meniscus. Then delta P equals TOR. Radius of this part is not x. X is the diameter. That is x over 2. X over 2. Then that is 2T over x. 2T over x. Right? And pressure difference is exactly equivalent to the rise. No? Pressure difference is exactly equivalent to the rise. Then this delta V equals, say that is capital H rho g equals 2T over x. 2T over x. Right? Say this is equation 2. Now I have two equations, 1 and 2. Right? 1 is here. Okay. Then 1 over 2. Then 1 over 2. 1 is simple H rho g. Simple H rho g over second one capital H rho g. Right? Equals from first one 2D over R. From second one 2D over x like this. Then 2D to 2D to rho g cancels. Right? Then we need capital H. We need capital H. Then simple H over capital H equals is a good one. Right? Simple x. X is found. Where was x? See, x is r minus d. X is r minus d. Then r minus d over simple r. Capital H equals simple hr over r minus d. Simple hr over r minus d. Answer is 4. And since it is a cylindrical meniscus, this question is again very important. This is a cylindrical meniscus. Right? Pressure difference of a cylindrical meniscus is T over R. Right? We have basically three types of menisci, no? For spherical ones, spherical drops, 2D over R. For soap menisci, 4D over R. For cylindrical, T over R. Right? That's a good one. 49. 49. 49. The voltages in the figure 2 are given for A and B inputs of a SR flip-flop as shown in the figure. The input one of the NAND gate is binary 1. Voltage 5 volts. Which choice gives the output? Okay. Output F. So we know this is a flip-flop. Right? About a flip-flop. Now that is a S to Q, R to Q bar. Right? Which means, right, you have to know what is inside here. That's a flip-flop. Right? Now the flip-flop is like this. Right? Flip-flop inside the circuit is like this. Right? Without having this idea, right, we can't do anything. So this is a flip-flop inside that. Right? And this is given as S. This is R. And in front of S, Q. Here, Q bar. Right? Now, first thing is, you have to know the truth table or the values of this given flip-flop. Right? Then SR, Q, Q bar. SR, Q bar. Q bar. Right? Then these are the values it is going to get. These are the values it is going to get. 0, 0, 1, 1, 0, 1, 0, 1. Right? When both are 0, 0, can't simplify. That is called the unchanged state. Unchanged. Flip-flop functions from the memory. Right? In that state, flip-flop functions from the memory. 1, 1 is invalid because same answer is coming for Q and Q bar. 1, 1 is invalid. Right? Then when R equals 1, when R equals 1, 1 plus anything is 1, its bar is 0, then q bar becomes 0, this is 1, then this is 0, 1. Right. Then for this case, SC is also given as A. Now SC is given as A and R is given as B. Right. Okay, then if I simplify the NAND gate, here, right, then output of the NAND is Q is coming from above, 1 is coming from below, then Q dot 1, it's bar. Then that output is Q dot 1 is Q bar. Then the output is going to be Q bar. Right? Here, 3 time intervals are given. Right? This is one of the time intervals. This is the second, third, fourth. Some time intervals are given. Right? Then check this time interval to time interval. Right? First one, A is 0 and B is 5. A is 0, B is 5 means, right? A is 0, B 5 means 1. Right? 0, 1. Then Q becomes 1. Check the truth table. That is relevant to this line. That is the one relevant to this line. See? That is the one relevant to this line. See? This line. See? This line. This one. Right? A0, B5. Then Q bar 0. Q bar is 0. Right? Q bar is, sorry, S0, S0, A is 0, first line, no? A is 0, B is 5, right? Then 0, 5 means 0, 1, then Q bar is 0. Then for the first time interval, Q bar is 0. Then second time interval, A is 1, and B is 0. A is 1, B is 0, 1, 0 means Q becomes 0. Then Q bar is 1. Then Q bar becomes 1. Third time interval 0, 0, unchanged. Unchanged means this 1 is unchanged. Then the next one, A1, B0. A1, B0 means A1, B0. Again, the same state, no? Same state. Then Q bar is still 1. And last one, 0, 0 again, right? Sorry, third one is A1, B0. A1, B0. Hurry check. A1, B0. 1, hurry. Now I think we can get the answer. Right? It is 0, 0, and 1, 1, 1. Right? 0 and 1, 1, 1. Zero and 1, 1, 1. No, there's an error in the question. The error is this. The error is this. There is an error. Error is this RS should be switched. Right? This RS should be switched as in the standard way. See? Now let me correct that error. This R and S should be switched. See? These two should be switched. This should be R, this should be S. Right? Then if that error is corrected, this is how my truth table is going to change. See? That is the error. I thought it's correct. And they have intentionally switched S and R. No, that's an error. Then when R equals 1, Q becomes 0. When R equals 1, then this is RS, no? RS, then R equals 1, Q should become R equals 1. And these two are also opposite now, different now. R and S. Then R1 line R1. Then 1 plus anything is 1, Q is 0. Then 0, 1, 1, 0. This is how it should be. Right, now we can check. Now for the first time interval, A0, B5. A0, B1 then make A0, B1. Right? For the second time interval, right? Then A should be R. Then let me correct the error. Then AB also they should be different. RS change and AB change, you know. Wait. There is an error. I'm correcting it. R is 1, 1 plus anything is 1, it was 0. Then, yeah, these two should be switched, right? Otherwise, I don't see an answer here in the given list, right? These two should be switched. A and B should be switched, right? Right. Then, if A and B are switched, this is what we have now, right? Now, even though this is a provincial paper, there is an error, right? Then R is B, S is A, right? Right. Then check kar balo. Then for the first case, A is 0, right? A is 0 and B is 1. A0 B1 means this line. A0 B1, then Q bar becomes 1. Then in that case, Q bar becomes 1. Q bar becomes 1. Right? Q bar becomes 1. Green I will be writing the revised answers in green. Right. I will be writing the revised answers in green. I will be writing the revised answers in green. Okay, then in that case, this becomes 1. Then for the second one, B0 and A1. B0, A1 means, now from this, B0, A1 is this. Then Q bar becomes 0. Then here Q bar becomes 0. Q bar becomes 0. And next one, 0, 0, memory, 0. Then fourth one, A is 1 and B is 0. A1, B0 means, again this one, where Q becomes 1. Right, then 1001, no? 1001, that's in answer 3. Right? 1001, 5005. Right? That's enough to check. And this was the error. R and S should be switched along with AB. R and S should be switched along with AB, otherwise you can't do it. Right? So I corrected that error. Right, otherwise the coming answer is not given in the list. Right. 50. Last one. The uniform magnetic field of flux density 1.7 acts into the plane of the paper at right angles to it. A proton P enters the magnetic field from W, right? And right angle to W exit leaves the field from Y. Okay, which means it travels in an exact circle here. No? This is an exact circle. Then only it can be right angled. Right? Then only it can be right angled. Then we know that is inside the magnetic field. Let's say the velocity here is V and velocity of the particle here is also V. Right? That is inside the magnetic field. Radius inside a magnetic field. Radius of a particle inside a magnetic field is given by R equals, that is a proved equation, mv over vq. Right? That is given by R equals mv over vq. Now, using this, now radius is given 1 centimeter. Then 1 times 10 to the power minus 2. Mass is given, mass 1.7 10 to the power minus 7. 1.7 10 to the power minus 27. I need V, right? Over B is also 1.7 and Q is 1.6 10 to the power minus 19. No? Right, then 1.7 to 1.7 cancels. Then V is 1.6 10 to the power minus 19 and minus 27 means 8. Then plus 8, it becomes plus 6. Ne? Then V is 1.6 10 to the power minus 6. V is known. Then it says an electric field of intensity 1.7 10 to the power 3 at right angles to XY and length L. The proton P moves in electric field within the time of 10 microseconds. Okay. Then for the electric field, first I need acceleration of the particle. Now, on the proton, there is an acceleration to the direction of electric field. There is an acceleration to the direction of electric field. Let's say A, right? Let's say A, and acceleration in an electric field is given by QV over M. That is also a proved equation. QV over M, right? QV over M. Then I need acceleration. Q is 1.6 10 to the power minus 19, right? And E is 1.7 10 to the power 3, 1.7 10 to the power 3 over mass is 1.7 10 to the power minus 27, right? Then 1.7 to 1.7 cancels off. Then the acceleration is given by, right, 1.6 and 10 to the power minus 27. Then plus 8, it becomes 11. Then 10 to the power 11. 10 to the power 11. Acceleration is also known. Now, for the motion of proton inside the electric field, you can use an equation like S equals UD plus half AD squared. Right? Then S is L, no? S is L. U is V. V is here 1.6 10 to the power 6. 1.6 10 to the power 6. And T 10 microseconds. Then 10 times 10 to the power minus 6, 10 microseconds. Right? Plus, not plus actually, because now I'm applying the equation in the rightward direction, but the acceleration is opposite. Acceleration is opposite. So that is actually a deceleration. Minus half A. A was 1.6 10 to the power 11. Right? Then T squared. Right? This is T, no? This is T. That is 10 to the power minus 5. Then 10 to the power minus 10 square. Square is 10 to the power minus 10. 10 microseconds, it's squared value. Then simplify this. 10 to the power 6 to minus 6 cancels. Then this is 16 minus here 10 to the power minus 11 and minus 10 means only 10 remains. Then 16 over 2, that is 8. 16 minus 8, 8 meters. That's a good question. 8 meters, then length equals to 8 meters, right? That's a very good combination of a magnetic field and an electric field. That's a very good combination of a magnetic field and an electric field, right? So that is 8 meters. That is 8 meters, right? So with that, we have come to the end of the all questions. End of the all questions, right? Any questions? So anything to know, anything to clarify from my side before we wind up the session? Anything to clarify? And I have recently uploaded 2 videos on DTL and TTL logics, right? So you also can watch those 2 as well, because this time it is important to know about DTL and TTL, right? It is important to know about DTL and TTL before you go to the exam, right? Since most of the students were asking and they were like kind of afraid and fear of DTL and TTL, I recorded 2 videos and I uploaded, right? Just go through those videos also and get an idea how DTL and TTL works, right? That is something that you must know before you go to the exam this time, right? That is something you must know before you go to the exam this time, right? That is important this time, right? We practice some of those questions in the paper classes also, right? And again, if you need to recall, right, just watch the videos and recall it, right? Diode transistor logics and transistor logics, DTL and ETLs, right? Okay, then the other essay discussions are also going on. So probably tomorrow we'll be having an essay discussion, right? We'll be having an essay discussion. I'll inform what lessons I'm going to take to the essay discussion, right? And the other paper discussions and all the discussions are also coming up in the next week also. There will be discussions. So even though the theory classes are over by now, right? Even though the theory classes are over, we'll be having the question discussions like this until you go to the exam, until you sit for the exam. And sometimes I will upload some other recorded videos also, so you can watch them in a free time and get those ideas. All right, then no questions. If no questions, we'll wind up. Then see you in the next class or next session. Stay safe and work hard these days, right? Last 11 days. All right, then see you in the next session or next class. Good night.